So hello again, and in this video I'm going to show you how to georeference an aerial photograph using QGIS. And we downloaded some aerial photographs from the USGS Earth Explorer, and I have another video showing that. In this one you will see how to install the QGIS Georeferencer and how to select control points in a reference image and how to transform the image that doesn't have a reference. I will use additional resources here from ArcGIS when I give this presentation, and in fact I personally prefer to georeference in ArcGIS, but given the current situation that we have, we need to depend on open source software. Okay, so originally we had downloaded some images, which is this one. Let's see if I can open it. So we had downloaded this image, which is an image of UNC, and this one doesn't have a reference. And we also had downloaded a high resolution image. And in fact, let me go ahead and bring that image to QGIS. I'm going to do a drag and drop, of the high resolution ortho imagery. And the high resolution ortho imagery is already rectified, right? And you can see that it has the coordinates and it has a projection in state plate projection in North Carolina. And I'm just going to work with this section here only. So I'm planning only to rectify an area around this area, okay, of the image. So when I go to my historical image, let's go back to my historical images. Let me open this one and let me open the second one. So I downloaded two consecutive images, and you should notice it. Let's see if I can show it like this. So the airplane was going in this direction, going like this, and took a picture, and then looked over the landscape, and it took another picture. And that's why you, in one image, you see like our area of interest here, and then in the next image the area of interest is over here. And in photographs like this one, the place where there's less distortion is the center, and as we move to the edges, there's more distortions for multiple reasons which I will not discuss here. But looking at these two images, and in fact you can see also some glare in the edges of the image, but for the sake of this example, then what I'm going to do is I'm going to take this and a section from this image which probably has less distortion, because as you can see this one is farther away from the center, right? It's closer to the corner. So I'm going to go ahead and say, okay, well, I'm going to work with this area. This is the area that I'm interested. I'm just going to go ahead and crop it. With a Mac, it's fairly quickly to do this in preview, but you can do this also in Windows, or you can use GIMP or anything that will crop an image. I'm gonna go ahead and save it. And let me zoom out a little bit here. And this is our image that is referenced, right? So let me go ahead and look again the image that I just cropped, which is this one. Probably you should have saved a copy before cropping it, but I'm gonna go ahead and stay this way. And you can see that I have to give it a rotation. So I'm gonna go ahead and rotate it like this, right? So you can see that the baseball field is facing in the same direction, okay? So now they're both in the same direction, and that will make things much easier later on to rectify it. Again, if you have ArcGIS, this is a much better thing to do in ArcGIS than in QGIS, but again, given the circumstances, we're going to use QGIS. Okay, so now I have rotated the image, and that will make things much easier later. So in QGIS, we need to use the plugin. So go to plugins. Maybe you cannot see it right now in my screencast, but go to plugins, go to manage and install plugins, and make sure that Georeferencer is clicked. Georeferencer is Giotto. So search here for Georeferencer. So what did I do? Georeferencer, Giotto, and make sure that it's clicked. And then on the raster, which again you cannot see here in my screencast, but know that you have something that says raster, go to Georeferencer, and that will bring this window. Okay, so in that window, we're gonna click this button, and we're gonna select the image that we're going to reference. Okay, I repeat, we're going to open the image that does not have a geographic reference, so the one that we're going to reference, which is this one. Okay, this is the older image and the one that does not have a geographic reference yet, but we're gonna do it now. So the thing that we're gonna do is match things that we see in this image with the image that has a reference, that has a coordinate system. Okay, so how do we do that? So here we click on add a point, and what we're gonna do is add a ground control point. Ideally, we're gonna use points from the ground because there's less distortion, but since it's a video that I'm trying to do fast, I'm gonna start getting points that are just relatively similar, so we can start getting some similarities between the images. And you can see this buildings which creating some X's. So in fact, I'm just gonna go ahead and zoom in there. Let me go to the one in the north west. And I'm gonna select that point over there. So I'm gonna go click here. I'm gonna click in this point here. And if you were dealing with another type of data set, like for instance a map that already has a historical map that has some grid, or you already had some control points that you grabbed from a GPS, then you can enter them here. But in our case, we're just gonna click here from map canvas. So click this button. This will take us to QGIS, and we're just gonna zoom into the place where I had selected that point. I hope I'm remembering correctly where I had selected that. And then you get this window, which is indicating, well, that control point has this value. And we're gonna click OK. Again, I recommend you could do this with tiles. Use the reference from the tiles, but I usually prefer using high resolution orthoimagery because I know that they're done well. They don't have the distortion that tiles causes, and I know the projection, and we have much more control. So if we go back to our data, then we know what we use for controlling our data set. So again, so you can see now that the image, and as well as our our historical image here and the ortho are showing some points, right? And they match. Again, in an ideal world, you would have control points that are in the ground and not in the buildings, but ideal is very difficult to find sometimes with historical images. And ideal is not the situation that we're right now. And I am going to go get another point. So we go again here, and I click here, again from canvas. If you start clicking and you don't see a point or nothing happening, it might be that this window, it's behind some other window. So just take that into consideration. Click from map, and now let's look for that other place. Let's hope I didn't mess up the point. I guess I needed to do that earlier. So let me go here again and click from map, and now click from map. Click OK. Good. So now let's find another one. Let's find this one. So let me be ahead of time and move to that place. So here's gonna be the other one. So okay, so add a point, click here from map. Good. Click OK. Looks good. Let's zoom. Let's move with the hand. Let me just gonna go get this one over here. Again, let me move to the place I'm gonna be later on. Okay, so click here from map, and there we go. Click OK. So now we have 4 points, and you should be saving this work. So let's save it by clicking here and go ahead and call it ground control points, Chapel Hill 2002. Okay, and now we go to this icon to determine the methods that we're going to apply. Initially you might have a linear model, but let's start with a polynomial model. And this data set, it's a continuous raster, so we could apply a cubic transformation. That will be the method that we should be using for a continuous data set. However, nearest neighbor is faster, and for the sake of the video, I'm going to use nearest neighbor. Also, nearest neighbor would be the method of resampling that you should use if it's a categorical data set. I will show another video on the theory and what all those things mean, as well as the transformation types. But for the moment, I'm going to focus here on the technicalities, and let's see where it's going to be saved. Okay, it's going to be saved there. Sounds good. And it's going to accept the projection of the high resolution orthoimagery, which is in the state plane of North Carolina. Let's click OK. And what I did there is just put the settings. So if I want to do the referencing, I click here at the play button, and which will do the start georeferencing. And it will do it very quick. That's the beauty of Giotto. And we can open it. Let's do a little drag and drop. This is the modified one. Okay, so I have referenced it, and it looks fairly good, at least in the area where the point is. Okay, so it's looking pretty good. See, if I unclick the older image, then I can see the changes in the area. Okay, so this has been a quick way of referencing. One of the things that we can do is start initially getting a few points that you can quickly see where they're located, and then start trying to find more refined points to make the rectification better, and also so you can use other types of models that might need more points for creating. So one of the ways that you can do that is, okay, so now we have this here. Let me actually do a duplicate of my reference, sorry, from my georeferenced image. And that one, I'm going to make it a little more transparent. So for instance, you can see a little bit the overlay. And again, in ArcGIS, this is very easy because then you can play with the rotation and the transparencies. But this allows us then to see a little bit better the distortion. But okay, so let me find another point, and I'm gonna find a point that hopefully it's a little more in the ground and not over a building, because again, the building will have a shift given the fact that it has elevation. And I'm gonna find something in the ground here. I'm pretty sure this hasn't changed. I mean, I've been looking at this image for, yeah, I can see this point here has not changed, and it's in the floor. So I'm gonna go ahead and zoom there. Let's see where it's in our image. See, and the image is over here. So, but it looks the same, right? It actually is, it was the same place. So I think I can use it as a control, because the problem is that you should never use things that have changed, right? You need to use things that look the same in the past as in the present. So actually, now that I look at it, it doesn't look like it's the same. Oh no, it's the same. Okay, let's go ahead and use it. Okay, so this is my reference one, right? This is the ortho image, and let's go to our referencer. See where is that place? So over here, over here, over here. So let me put a point there, and let's look for it in the map, which is here. Great. Accept that. And now, since we have already created a model, it will give us some error, all right? And this error is misleading because this error is based on assuming that all the other points were correct, which again, I doubt that they were as good as this one because we were basing it on the top of a building. Okay, so, but since I don't want to bore you with looking at a lot of different points, let's go ahead and just find another point. And one of the ways to make this look very nice is that if we collect points from all over the image, and that's usually very difficult to find. But in the ideal world, you will have a few points here, a few points going in this direction, and a few points in this direction. So you have a distribution of points all over the image, and that would allow you to make a nice rectification. Let's go around here so we can have some points around in this area. And let's see, maybe I can use something from this stadium. Let me go to the but the stadium is outside of our area, and also the stadium has changed. Look, the stadium has changed. All right, so let's look for something around close to the stadium. I'm just gonna go ahead and use this roof. Look, this roof, I just noticed this over here. Let's see. Yeah, it's that one over here. So I'm just gonna go ahead and use that roof. Okay, again, roofs are not the ideal, but I mean, it's better than nothing. So I'm just gonna take that point over here and that point over there. Okay, so let's add another point. It's this one here. Where it's that window. Here's that window. And now select from canvas, and I'm gonna select that point here. Good. Okay. Why I didn't see any error? That ain't good. If you don't like the point, yeah, I think seems like I have an error with wherever I located that point. Okay, so let me delete that point, which I can, or unclick it. I just unclick it, and now it's not being taken into consideration. Or I can, let's see if I can delete it by, this is to delete the point that it's, let me go ahead and delete the point. Where is it located supposedly? Yeah, something wrong happened here. I don't know how we ended up clicking there. Okay, so I deleted it. So now let's go back to the place where we're supposed to click. Let's go back again here. And we need to click first the image that we're gonna reference. Good. And now I go to my referenced image. And for the window. Click OK, and now okay, good. So I guess I clicked things out of order, and that will happen very often, so don't worry about it. But now you know how to delete. And again, let's save our data, our work. Just gonna save it by clicking here and give it a new version. Version 2. Okay, we're saving our work. And other things that we now have more points, so we can use another model like the polynomial, second polynomial, and we can just run this again and get a new referenced image. Let's hit play. Good. And now let's open that new version, and oh, it looks so much better. And look at the older version. Well, that's the transparency one. This is the older version, and now you can see how nice is this one. with the second polynomial and with having more points. The more points that you have, the better, but only if the points are well distributed and if they're good points. If you have bad points, meaning that you're collecting information that erroneous, like I showed you previously, then definitely it's not going to work as well. And one way to see how good your points are doing, it's by looking at the error in the here, right? So here you have the X and the Y on the image that you're referencing, right? The image that you're going to transform, the historical image. And here, the X and the Y of the values in the rectified image, right? In the ortho image. Here, the delta X and the delta Y is the difference between what is the expected and the observed of your model. And so we are here calculating what is the expected values versus the observed. So the lower the error, and you can see that the errors are very low right now with this model, the better is your model of transformation. So let me change it to, again, to polynomial 1 or linear. You can see that the errors should change, assuming that QGIS works like other software. See, and you can see that the errors are a little bit bigger. This doesn't necessarily mean that polynomial 1 is necessarily better than polynomial 2. And now that we're ready, I would go with the cubic resampling, again, because it's a continuous data set. And let's hit OK. And now I'm going to go and click play. Good. And let's see how that came out. Let's open it here. Looks really similar to the other one, and that's expected. And here we go. And you can see that there's some distortion out there, right? Because we have it's a second polynomial model, but in the area where we're interested, there's relatively little distortion. But let's compare it to the one that had the first order polynomial. You can see that it's not as distorted in the edges of the image. Well, hopefully this has shown you how to georeference a historical image.